Hello, today I am continuing my work on this project, and I just want to recap and see how long that I've gotten so far and what's the next step. So far I can control my robot using a Wi-Fi connection. This is then going to be, this rail, imagine it to be, this is one section, imagine it to be several sections longer. And it's going to have on it an arm. I have a rendering of sort of what it will look like. But the next step for me now is to build the arm. And I have I call it also like the Lego kit for robotics. So I want to use a few like generic 3D printed parts together with the PVC pipes, together with ball bearings as in here, and using these parts together it should be possible to get a robot to do actual real useful work like growing vegetables. So this is now going to be the next part. The arm is somehow going to come here, and what I have tested here is just the actual hinging part. So I'm reusing this part here. It's the same as I can use also here. And so that works so far. And then the actual thing that is going to make it move, instead of cogwheels and gears, which I think is going to be complicated to 3D print, I will try to use a threaded rod like this one. It's going to be much shorter. This is somehow going to be attached like an excavator, like how a hydraulic thing in an excavator, but instead of a hydraulic thing it will be this thing spinning with a motor. And I've made like a simulation in Freecad that I would also like to show you. So this is my CAD program Freecad, which is open source, and I really like it. And here I have a model of the arm. So again, the rail will then go down here, and here this is where the plant will be that it's going to be interacted with. And the challenge now is to first calculate the angles here and here. That's part of a much bigger problem called inverse kinematics that I've recently learned a little bit about. And inverse kinematics is a big problem, a huge mathematical problem. And I'm solving it a little bit different, because for me it's important that I'm using as cheap hardware as I can, and my microcontroller that I'm using, it's essentially just $5. So I would like to, instead of solving the equations numerically, I am solving them analytically, which means that they will not be as generic. They can't have as many links as they could have had if it was a generic inverse kinematic solution. But anyway, I'm not going to go in too much to that. But what this design is actually all about is the this thing here. That's now going to be this thing here, and up inside of this thing, that's where the nut will be locked. Imagine that this part here is roughly maybe 20 centimeters, so about this long. I'm going to cut this off, attach a motor here that can spin. I can spin this, and I think that's going to be a cheap and easy solution, and avoid having to have complicated mechanical parts, because ball bearings, PVC pipes, and 3D printing parts, that's what I want to build my robot out of. But anyway, the simulation that I've made is I can just move the the ball out here and see how the other things follow. And there will be a few calculations that I'm doing here. First I need to calculate the angles over here and over here. But then, since I want to use this approach with a rod that sort of pulls the arm in, I will have to calculate also the length here, given the angle here. What's going to be the length here? And then I can divide that with with the distance for the grooves here. And I can't see why that wouldn't work. And that is the thing that drives me forward. I really want to see this thing work. And at the same time, I thought I would be done by now. I'm not. So slowly by slowly. But so reaching out as well. Whoever wants to help out with this project and who is excited about robotics, and especially how robots can be used for day-to-day, everyday problems, or how robots can be used by us all to create freedom and individual freedom and create a world where we are just allowed to be without having to buy into the system. Can I say that? Yeah. If that way of thinking appeals to you, then that's what this project is all about. But so with that, if you made it to the end, thank you very much, and see you next time.